Okay, so picture this. You find this awesome data set. You're thinking this is going to unlock something amazing, but then you open it up and it's just a jumbled mess. Data files you can't understand at a glance.
Oh, I bet that's a pain. So how do we avoid that kind of mix-up?
That's where README files come in. They're like having a friend who can walk you through the whole thing. They can save you so much time and frustration.
Let's start with the basics. What exactly is a README file and why is it so important, especially when we're working with other people?
A README file tells you who created the data, where the data was created, method used to produce the data, sharing privileges, and so on. If a data set contains multiple files, a README file is intended to help ensure that the data can be correctly interpreted by yourself later or by others.
And I guess it stops those future moments like when I open up an old file and I have no idea what it is.
Exactly. It's like a user manual for your future self and others. When it comes to collaboration, README files can prevent misunderstandings and make sure that everybody interprets and uses the data in the same way.
I agree. README files are definitely worth it. But what should we include in a README file? Is there a checklist or something?
First, you've got general information. Provide the basic who, what, when, where of the data, like the title of the data set, contact information for the person who is responsible for the data, date of data collection or generation, geographic location of data collection, and maybe funding sources.
It's all about context.
Exactly.
What's coming next?
Next, you've got the sharing and access. This is where you talk about licenses, data sources, if your data is derived from another one, and links to publications that cite or use the data.
So, this is how we facilitate the reuse of data and make sure that everything is being used in the right way. It's all about data sharing and reuse, right?
Right. Then you've got the data and file overview. This is where you describe each file in detail, like what data it contains, its format, any relationships between the files, and date that the file was updated or versioned. For example, if you have one file with raw data and another one with processed data, you should explain how they're connected.
I see.
And then you have the methodological information section, and this is where you describe how the data was collected or generated, how the data was processed, any software or instrument needed to interpret the data, and even quality assurance procedures.
It's all about transparency and reproducibility, right? Making sure that someone could do it again.
Exactly. If someone wants to use your data, they need to know how it was put together and whether it's reliable.
Now, what about those cases where the data has codes or symbols? How do we make sure that everyone understands what all that means?
Well, that's where the data dictionary comes in. Think of it like a glossary for your data. You define all the special terms and codes so that everyone can interpret the data in the same way. It's really important when you're dealing with complex data sets.
Okay, so that's super helpful. It's like having a decoder ring for my data. It's amazing how much goes into creating a really good README file. So, we've covered what goes into README files, but I'm curious, what are your top tips? How do we make these READMEs really shine?
Oh, absolutely. A good README file is not just about the information itself, it's how you present it.
So, presentation matters.
Yeah, first, keep it simple with the formatting. Stick to plain text, rich text, or markdown formats. Those are readable by pretty much anything.
That makes sense.
And speaking of keeping things simple, use templates. Templates are a game changer. They give you the structure, right? You follow it and you know you're not going to miss anything important.
Yeah, templates are great for that. Any other practical tips?
Yeah, keep it concise and informative. You want to get across the most important stuff without overwhelming the reader. Use headings, line breaks, and bullet points for readability. Nobody wants to read a wall of text.
It's all about making it scannable so people can find what they need quickly.
Speaking of finding information quickly, you can provide file naming conventions. Be super clear about how you've organized everything and what each file contains.
Oh, that makes a ton of sense. It's like having a well-organized folder structure, right?
Exactly. And remember, don't assume that everyone knows everything. Spell out those abbreviations, define variables and their units of measurement.
So, I should include a data dictionary for my data.
Right? And if you use the specific versions of software and packages for analysis, make sure to mention them so others can reproduce your work.
Right? Reproducibility is so important in research.
Absolutely. And if your data is linked to any publications, please include the links. It gives context and credibility.
It's like providing references for my data, right?
Yeah. Now, here's a trap. Don't just copy and paste your methods section from your research paper into the README file. I mean, yeah, methods are important, but the README file should really focus on explaining the data itself.
So, it's all about tailoring the information to the person who's actually going to be using it.
You got it. And finally, don't be afraid to include specific instructions if needed, like how to handle data, troubleshoot any problems, that sort of thing.
Okay, we've covered so much. I think it's time to wrap up.
Yeah, when you take the time to write a good README file, you're not just documenting your data, you're making it easier for others to collaborate to build on your work, maybe even make new discoveries.
Okay, I'm convinced. We can make our data more usable and impactful. Thank you for joining us.